Synchronous replication in master-slave architecture. So synchronous replication in master-slave primary or primary-secondary architecture ensures that the data written to the master primary is immediately replicated to the slave, which is the secondary, before the write operation is considered successfully. This guarantees that the data is consistent across both the master and the slave at any given moment, as both are always in sync. In this setup, the master sends the data changes to the slave and waits for the slave to acknowledge that the data has been successfully written before confirming the write operation to the client. This ensures that data is replicated in real time and provides strong data consistency between the master and the slave. Okay, so if you don't know actually what is a master slave architecture in database, there is a video. We created a video with that. You can check it if you want, but let's just try to assume that you don't know. So we'll just try to make a small recap. So if the server or the client trying to send a request to a master slave architecture database, we have the master will serve all the write operations, and the slave will serve all the slaves, because we have two slaves, will serve all the read operations. And when there is a write operations like insert, update, or delete happen to the master will replicate these data to the slaves. And there's two ways on how the data being replicated: is synchronous replication or asynchronous replication. There are two ways. And we're using the master slave architecture because it provides high availability and scalability. Because if we have one when database server and the database server went down, we cannot access our data anymore. But in the master slave architecture, if one master went down, one of the slaves could be promoted to be a master. If one of the slave went down, we have two databases still. So our applications will be we will increase the availability, fault tolerance, and redundancy, and also the load on the master database, because right now the read operations have been served by the slaves and not the master. So it's overall a great architecture to use. Today we will try to talk about how the replication is working, and we focus right now on the synchronous replication. So let's try to see. So right now, a client or the server sends a write request, insert, update, or delete to the master. Okay, let me just try to make the slaves quiet away so we will understand everything here. Yep, it will send a write request to the master. The master processes the write request. The master server processes the write request and prepare the data for replication. And then the data should be replicated to the slaves. So the master will replicate. The master sends data to the slaves and waits for the slaves to acknowledge that the data has been successfully replicated. And this is crucial step in synchronous replication, because the master does not commit the transaction until the slaves confirms. So let's say that the server is trying to add a new user, for example, to the master, and the master added the user to the master database, inserted the user, and it will replicate this user to all the other slaves, and it will wait for acknowledgement from the slaves that, yep, we added this new user. And when the acknowledgement from the slaves obtained, like when the slaves has successfully written the data, it sends an acknowledgement back to the master, indicating that the replication was successful. And after that, we have a client acknowledgement. So after receiving the acknowledgement from the slave, the master confirms the completion of the write operations to the client. Only then is the transaction considered finalized. So what we get from synchronous replications: first, as you can see, we get strong consistency, because the primary benefit of synchronization replication is strong consistency between the master and slave. The data on the slave is always up to date with master, because write is not completed until both slave has the same data. And also there is no data loss at all. No. Let me pull it back because, as you can see, again, there is no data loss at all. Like in case of a master failure, there is no risk of data loss because all data is already replicated in the slaves. This makes synchronous replication ideal for systems that cannot tolerate data loss, like financial systems. There are some sort of write latency because synchronous replication introduce additional latency in write operations. The master must wait for the slave to confirm that the data has been written before completing the transaction. This can slow down write performance, especially if there is significant network latency between the master and slave. Lastly, high availability, because if the master server fails, the slave contains the most recent data and can be quickly promoted to take over as a new master without any risk of data inconsistency or loss. So, as we said before, what is the advantages? First, we have consistency. Second, we have no data loss. Let's call it DL, data loss. 3, we have a simplified failover because in case of master failure, the slave can be promoted to the new master with minimal disruption, as the slave always has the latest data. This reduces the complexity of failover scenarios and ensure quickly recovery. It's also ideal for critical systems. Synchronous replication is ideal for systems that cannot afford to lose data under any circumstances, such as stock trading platforms, financial transactions, healthcare systems, or real-time monitoring systems. Okay, let's now talk about what are the disadvantages of the synchronous replication. The first thing, we did increase the write latency. And I guess this could be quite obvious. Synchronous replication introduces significant write latency because the master must wait for the slave to confirm the replication before finalizing the write. This is especially problematic if the master and slave are geographically distributed, causing a higher network latency. Also, we have a network dependency. So the overall performance of synchronous replication depends heavily on the quality and speed of network between the master and slave. Any network issues such as high latency or packet loss can degrade the system's performance. Synchronous comes with scalability limitations because the need for the master to wait for every slave's acknowledgement before committing a transaction limits scalability, especially in environments with multiple replicas. As more slaves are added, the replication process becomes slower, potentially creating a bottleneck for write-heavy workloads. Number 4, resource intensive. So synchronous replication can be resource intensive, requiring reliable network infrastructure and additional computing resources to ensure real-time data replication. This increases the operational costs of maintaining the system. So let's say in conclusion, synchronous replication is a master-slave architecture, provides strong consistency and guarantees zero data loss, making it an ideal choice for critical applications like financial systems, healthcare records, and real-time transaction processing. However, it introduces increased latency in write operations and is more dependent on network performance. It is important to know the trade-offs between strong consistency and performance before adopting synchronous replications, especially for large-scale or geographically distributed systems. So that's it for this video, and see you